Today's lesson is 3-1 and it's all about classifying triangles. So there's two ways to classify triangles. The first way is classification by angles, and the second way is classification by its sides. So let's get started with classifying by angles. So just as there were three different types of angles in triangles, that's also how we classify them. The first one is an acute triangle. So it's where all angles in the triangle are acute. So we're just going to draw a triangle. Okay, it's pretty acute. And then just to be certain, I'm going to go ahead and say, all right, we'll say that's 70 degrees. We'll say that one's 50 degrees, and we'll say that one is 60 degrees. Okay. Next one is obtuse. So an obtuse triangle is just a triangle that has at least one obtuse angle. Well, that did not pick up what I wanted. So it has at least one obtuse angle. And if you think about it, I guess I shouldn't say at least one obtuse. It has one obtuse angle, so I apologize. Because it cannot have more than one obtuse angle in it. So this angle here is our obtuse angle, and we'll say that's 120 degrees. And the third manner in which we could classify triangles is a right triangle. So a right triangle has exactly one right angle. The other two, and this is where sometimes people get confused, the other two angles may be acute. Just the same as the obtuse. Those two angles are also going to be acute. So sometimes people say, okay, I see two acute angles, it's an acute triangle. But remember, for an acute triangle, all of the angles have to be acute. So please be careful with that. Moving on to classifying by sides. Now this is just going to be based upon strictly on what we know about the sides, so what information we know. The first one is called a scaling triangle. And a triangle is scaling if all of the sides have different measures. So each side's a different length. So in order to demonstrate that, I'm going to put those little congruent marks in the sides, and they each have a different number. So the left side I put 1, the right side I put 2, and the third side I put 3 to show that none of them are congruent. The second one is an isosceles triangle. And in an isosceles triangle, and I'll draw this as accurate as I can, in an isosceles triangle, only 2 of the 3 sides are congruent. Okay, the third side is not. So at least 2 of the sides of the triangle are congruent. And lastly is an equilateral triangle. So that one doesn't look too equilateral, so let me retry. But an equilateral triangle has all 3 sides congruent. There we go, that's close enough. Okay, so all 3 sides are congruent for an equilateral triangle. So let's take a look at our first example using these classifications. So for example 1, it's asking us to classify it by its angles and sides. So angles, sides. I'm going to do that for every one, so that way we specifically know, because I will tell you sometimes maybe on a quiz or a test, it won't ask you for both. It's only going to ask you for one. So you need to make sure you know which classification is by its angles and which one's by its sides. All right, so this first one, I see 62, 59, and 59. So that's looking at its angles. So by its angles, they're all acute angles. So by angles, it's acute. And for sides, I have to look at the sides. And we're just looking for congruent markings or actual side lengths. So this one has no actual side lengths, but it does have these 2 congruent symbols. And that's 2 of them, so that means it's isosceles. For the second one by angles, I look at the angles up, I see this box, so that means it's a right triangle. And again, for the sides, I see those 2 congruent symbols, so it is isosceles. All right, for C, if I'm looking at its angles, I do see these 2 look pretty small, but then I see that 120 degrees, and that's an obtuse angle, so it's an obtuse triangle. guess I should be putting triangle after all of these. And by its sides, I don't see anything here. There's no congruent markings. So when we see no congruent markings, that means none of the sides are equal, so it's scaling. All right, D, again, I see that right angle, so it's a right triangle. And again, I don't see any congruent marks, so therefore it is scaling. Now for E. This one's a little bit tricky, and a lot of times for this one I get acute. And it might very well be an acute triangle because we do see two 42-degree angle measures, but we don't know the measure of that third one. And if that third one's acute, then great, it's an acute triangle. But if it's not acute, then it could be a right triangle if it ends up being 90 degrees, or it could be an obtuse triangle. So we need to take 180 and subtract 42 and then subtract another 42, or just 180 minus 84, and we get 96. So right away I'm thinking, well, 96, that's not an acute angle, so this triangle is actually an obtuse triangle because it has that one obtuse angle. It does have the two congruent sides, so it is isosceles. All right, and finally, I see 45, 50, and 80. And if you add them all up, we actually get 175, but either way, so I apologize. Maybe we can make this one 55. That works out a little bit better, but either way, it's still acute. And then none of the sides are the same, so it is scaling. All right, so in example 2, it's more the same type stuff. We're identifying triangles, but in this case, there's a whole bunch of triangles. So for part A, it said, identify the indicated triangles in the figure. If UV is congruent to VX, which is congruent to UX. So the first thing we have to identify is all the isosceles triangles. Now we can only go by what's in this figure. So I do see these two congruent marks. So, oh, and that's different from what they gave us. So I know that this triangle here is isosceles. So we're going to say triangle UTX. All right, the other information they gave us was that, I'm going to erase that first stuff, was that UV, so UV, and VX and UX, they're all congruent. So if we go back up here, the definition of an isosceles triangle says at least two sides. So that's an equilateral triangle, but it has at least two sides, so we are going to say triangle UVX is also technically an isosceles triangle. All right, and now they're asking for scaling. So scaling means all the sides are different. So those are the only marks we know. So just about every other triangle is going to be scaling, but let's double check. So let's look at, first of all, this one. I'll try highlighting them. UTX. And then we'll do the one that's very similar to it. So triangle XTZ. Okay, so we did those two. And then I will do the ones that are slightly bigger than that. So my VYX. And then we'll do the other one that looks very similar, the UVZ. Right, so we have those. Oh, and then here I see some other ones. This is sort of like those pictures where you have to find what's different. So we could do UZX. I don't think we have that one. Nope. And then with that same thing, we could do x, u, y. And then I'm pretty sure we just have one more. And that is going to be VWX. I am almost certain that is all of them. All right, if you find any more, don't hesitate to let me know. But it's like those fun puzzles where how many triangles are in this figure. All right, so example 3. It says find D and the measure of each side of equilateral triangle KLM. So key information here, equilateral triangle. That tells us that all the sides are equal. And we have to find D and each measure. So if I'm to find D, that means I can pick two sides, set them equal to each other, and go from there. So I'm just going to go ahead and pick the left side and the right side. So 4D minus 13 equals D plus 2, and then solve this for D. So I get 3D is equal to 15, D is equal to 5. All right, so we found D. Now we have to find the measure of each side, and they should all be the same. So say I do KL, because that is the easiest one. Well, that's D plus 2, which is 5 plus 2, so KL is 7. And every other side should still be 7, but we'll just double check. 12 minus 5, that's 7. 4 times 5 is 20. 20 minus 13 is 7. So it does work out. So for our final answer, we can write D equals 5, KL equals KM, which is equal to ML, which is equal to 7. So again, using a little bit of algebra, and the way to do this problem, we need to do it because it said equilateral triangle. So if you did not know what an equilateral triangle was, it would be a little bit difficult to start this problem. Now for our last example, it says find the measures of sides triangle RST and then classify it by its sides. So this is the fun one anytime they put them on a coordinate plane. We're going to have to do distance formula. All right, so I'm going to write the ordered pairs down. So the ordered pair for R is -1, -3. The ordered pair for S is 4, 4. And the ordered pair for T is 8, -1. So if I want to find R to S, and remember you could use Pythagorean theorem if you'd like. I'm going to do 4 plus 3, because minus a minus gives you that plus 4, I'll do the minus and -1 to show you that's a plus. And don't forget your square root. So we end up getting 4 plus 3 is 7, 7 squared is 49, plus 4 plus 1 is 5, 5 squared is 25. 49 plus 25, we get 74. Square root is 74. The next side, let's do RT. So R and T. So I'm going to do -1 plus 3 squared plus 8 plus 1 squared. Don't forget 2 negatives gave me those positives. So we get 2 squared, which is 4, plus 9 squared, which is 81. So we have the square root of 85. All right, and the last one we need to do is ST. So S to T, we're going to do -1 minus 4 squared plus 8 minus 4 squared. So we get -5 squared, which is 25, and then we get 4 squared, which is 16. So we get the square root of 41. So now if I'm looking at all of those, they're all different. So that means that triangle RST is scaling. All right, so it's a different way to have to classify them. All right, so if you want to try these, feel free. I will just go ahead and put all of the correct answers on here for you. But feel free to pause the video, work on each of them, and then check your work.